Today we're looking at how to calculate volumes in mathematics. So we'll start with this simple question. It says we should calculate point of intersection between the graphs y equal to 2x and y equal to x over 2. Then make a neat sketch of the graphs and then show the representative strip that you will use to calculate the volume when the area bounded by the graphs and the line x equal to 2 rotates about the y-axis. Okay, so I've just gone through the problem. I've underlined the most important things for me. So let me start with point of intersection. They've given us two graphs, y equal to 2x, that's equation number 1, y equal to x over 2, that is equation number 2. So you can see that the two equations all have y equal to 0. Oh, sorry, they all start with y equal to, so I can say equation 1 is the same thing as equation 2. Well, I substitute 1 into 2, that will tell me that 2x is equal to x over 2. Then to solve for x, I can start by killing the fraction. You just take the denominator, you multiply both sides, you will get 4x is equal to x, and that makes 3x is equal to 0 if x goes to the left. Then it tells us that x is 0, and if I substitute x into any equation that side, it equally tells me that y is 0. So all this tells us that the point of intersection is the point 0, 0. So those two graphs, they intersect at the origin. So now it's time to sketch the graphs. So from our knowledge of graphs, those graphs are all straight lines, and the point of intersection is the origin. So I will try to get a quick sketch of them. So if I'm sketching, that's my x and my y plane. I must not forget that there was another graph involved, x equal to 2. So it means if I'm done sketching, I must see 3 graphs. Then I will shape the region surrounded by the 3 graphs. So that is my origin. So my graph of x equal to 2, I can put it anywhere on the x-axis. So let's say this is where my 2 is. So this is x equal to 2. Then it's time to sketch the 2 graphs. So if I've put my 2 here, let's just say 1 is midway between x equal to 2. So now let's go to those 2 straight lines. To sketch a graph, you need at least 2 points. So we've got one of the point already, which is the origin. So if I want to sketch the first graph, y equal to 2x, since I need only 2 points and I've seen the origin, one thing I can do is I can take x equal to 2, substitute there, then into the equation, I see that x equal to 2 will go with 4, so I can put my 4 there. So when x is 2, I can get 4 there. If I like, I can do the same thing with 1, it will give me 2 somewhere there. So, but 2 points are enough. So to sketch this graph, all I need is to link this to that. So that is my sketch of x equal to 2, and then y equal to 2x. I want to do the same thing here. If I'm sketching this graph, x equal to y equal to x over 2, it must pass through the origin. Then if I need another point, because I need at least 2 points to sketch a straight line, then I can also take x equal to 2 and substitute into the equation. You see that y will be 2 over 2, which is 1. 1 can be somewhere halfway between 0 and 2. So if x is 2, y is 1. So it will be somewhere there. So I'm now linking the point of intersection to that. So now I get all my 3 graphs. What the question requires, the question said, calculate the point of intersection of those 2. We've done. Then after that, you indicate the region surrounded by those 2 graphs and the line x equal to 2, which means the point, the region we're indicating must be surrounded by 3 graphs. You see, 1, 2, 3. So I'm shading that portion surrounded by the 3 graphs. Then after that, you put a strip inside. So I always tell my students the strip is the most important thing in a graph because it helps select the formulas for solving for areas and volumes for you. After that, it also helps you know where to break your limit. So looking at that shaded portion, for me to put the correct strip there, I must put in my mind that the correct strip touches only two graphs all the times. The strip can either be vertical or horizontal. So you are now going to look at the two options and see which one will touch only two graphs all the times. If I take horizontal, for example, you see I'm touching two graphs, but when I come down here, one graph has changed. This tells me that horizontal strip will not be ideal, even though some people say you can cut it into two parts, put horizontal and put it there. It makes the question longer. But generally, I just need to check whether which one can touch only two graphs all the time. So see, horizontal is touching two graphs, but down here one graph has changed. So with that, I will eliminate horizontal. But if I go for vertical in the shaded portion, I keep on touching only the same two graphs. So my ideal strip here should be vertical. And the vertical strip or the strip you have selected, you can put it anywhere you like in the shaded portion, because by the way, it will always touch the same two graphs. So I will then extend it to touch an axis. This is very, very important for me, because it will tell me that any formula I want to use to calculate my volume or my area must end with a dx. Then, now that I've put my strip, another information it tells me is that since the strip is vertical, parallel to the y-axis, the two graphs the strip is touching must be labeled using y, because I use a vertical strip. So the graph above it, I will call it y1, that's my first graph. So that graph is the graph that passed at 4, it should be graph number 1, 2x, and my second graph is the graph below it. So that is x over 2. If you interchange y1 and y2, you will always end up with negative areas or negative volumes. But if you make sure that each time you have a vertical strip, the first graph is above, the second below, then your volume will always be positive. So then I'm done with the graphs. I've shaded the portion. I've put my strip inside, and it's telling me that my limit must be right on the x-axis because the strip is touching the x-axis. So now we are done with the A part. We can now go to the B to calculate the volume. So when I'm calculating the volume for Math N6, there are two methods. One method is called the disk, one is called the shell. Those formulas are all on page 5 of your formula sheet. But even if I don't know the difference between the two, which one am I going for, which one to go and copy, I can study the information. You see, the question said rotation about the y-axis. Each time I get that rotation, I must start my formula with Vy. If they will say you calculate for rotation about the x-axis, my formula will start with Vx. But rotation is y-axis, my formula starts with Vy. Then the strip always tells you how your formula ends. So my formula will end with dx. So if I now go to page 5 on my formula sheet to copy my formula, I'll be looking for that formula that starts with Vy and end with dx, and that's obviously the shell method. So my formula will be the integral from a to b. Then here they will simply write an xy. But you see that on your graph, you've got y1 and y2. So you put your x in the place of y, you put your y1 minus your y2. So that's your formula for calculating your volume. Then you can move on. Your a and b, you will go right in the x-axis because your strip says so. Your strip tells you how your formula ends and where you reach your limit. So I'm reading my limit on the x-axis where I started shading to where I stopped. That will be 0 to 2. Then my x is there, it has every right to be there because the formula ends with dx. Then my y1, you see it to be 2x. My y2 is x over 2, then dx. So 2x minus x over 2 is like 2 minus a half, which will be 3 over 2. So you get the integral from 0 to 2 of x times 3 over 2x dx. 3 over 2 is a constant. You can send it out to multiply there to give me 3 pi, the integral from 0 to 2 of x squared dx. So that is it. I can now do my integration. I get 3 pi into x cubed over 3 from 0 to 2. Then I substitute my limit. I'll get 3 pi. Upper limit is a 2. You get 2 cubed over 3. Then 3 pi. Lower limit is a 0. You get 0 cubed over 3, and the lower limit is 0, obvious. Then here the 3 will cancel the 3. 2 cube is 8, so your answer is 8 pi unit cube. If you like to put it in decimals, it's fine. So guys, that's how simple it is to calculate the volume. And this method we have used is called the shell method. And one thing you must know is that when you are using the shell method, for you to be sure that you are using the shell method for calculating volumes, you say that your strip will be parallel to the axis of rotation. In this question, the axis of rotation was the y-axis. The strip is parallel to that. Whenever the strip is perpendicular, it's the disk method. But as I've shown you, you can still get to your formula without even knowing whether it's disk or shell, since all those formulas are given to you on the formula sheet. Thank you very much.